Our next speaker, many of you probably know, is Eeva Latosuo, and she's an associate professor of outdoor studies here at APU, delivering courses in field intensives, for example, in snow science and technical climbing. Eeva continues to teach professional avalanche courses for the Alaska Avalanche School. In addition, she's an active member of the search and rescue community as an avalanche specialist for AMRG. And more recently, she has started her doctoral research in avalanche risk communication at Simon Fraser University under the guidance of Pascal Bailey. This will keep her brains busy for the next few years. Eeva also was super helpful in helping put this event on, and her talk is going to be a recap highlights of the recent International Snow Science Workshop found in Oregon. Welcome.
Let's try this one. Thanks. It's great to step on this wall after hearing and great talk about our research. And it's kind of like, I don't know if it's a blessing or a curse to try to tell about somebody else's research. So we'll see how I'm going to do here. But I'm going to do a recap and highlights of the ISSW that many of you already know. So 6% of the attendants in then were from Alaska. Thank you so much for the stats analysis and organizing the picture. But it's actually, I really need to see that we are a really active avalanche community. And we also made a lot of presentations. I didn't count the presentations, but there were many. There were many oral presentations and posters from Alaskans. And then when I got this opportunity to do the highlights reel, I reached out to a bunch of people. That was like the best part about putting this talk together, is I sent emails out to a bunch of folks. I'm like, hey, what did you think was like worthwhile or a theme that percolated up? So truly, the next 20 minutes, which won't really make it's not gonna even start touching the true value of attending these conferences yourself. But I'm trying to make up a little bit of a highlight reel with the help from my friends. Okay, so the first highlight, or not, but at least it was very memorable. So while it was the first ISSW in person since the pandemic, we were really excited to socialize. But it didn't go as smoothly as we thought, and approximately 1/3 of the participants got the infection during the events. Other kind of memorable, there was a power outage that impacted the whole band, but no problem because we're all outdoor professionals. We really truly enjoyed the first ever outside session, and it never happened at ISSW. And thanks for the organizers who were pivoting very quickly with minimal consequences. So one of the panels that was slated for this day that had to do with the resilience and mental health in this profession got cut short, and I do think that was a big downer for the squirrel to get in the power box, and that was the biggest consequence. Another important thing is every time we have these conferences, we try to celebrate the female professionals that have done their work in this field, because even in this room, if you look around, there are women here, but it is there's a gender imbalance in this field. So in these times of professional networking, we'll try to make room to make sure that women get their sense. And this year, there were 5 people that got ISSW Eeva Award. And as you can see that there are 3 of them here in Alaska. Let's give a hand for Wendy Wagner, Ali Parker, and myself. We do have a really strong female presence here in this state, so we're happy with that. In addition, Janet Kellum from Idaho she was the first ever female to get the highest A3 service work permit award this year. Yet it seemed like there wasn't enough female researchers presenting. The organizers were trying really hard to have enough women in there, but it's just really hard in this profession. So give a big hand for people like Anne, who has presented and continued this work throughout its being in a minority. Okay, so are you guys ready for a deep dive? So these next themes, I have about maybe 10 slides, are kind of themes, and like I said, I won't do any justice at all on this, these talks, but I'm like picking up themes that I think all of you should kind of walk away with, and I'll give you some tidbits later on how you can find some of this work. Okay, so one word to remember from this ISW, super share. So, say it aloud, super share, super share, okay. So I've been going to ISWs for a long time, and every time I'm like really working hard, I'm like fully caffeinated. I go there to listen to these avalanche mechanics, avalanche formation talks, and I've seen this go. I've learned so much in the last 20 years, and it feels like we're like arriving in this place where a bunch of things that didn't really connect together, or we would go back and forth with different theoretical models from engineering world, and now it feels like things are actually feeling like it's making sense. So what these guys were looking at is they were looking at force simulations and field experiments, and they were doing video analysis of real avalanches in real mountains walking away. And they came to this conclusion that crack propagation reaches stationary speed if the snow column is long enough. So all this time that we've been working first with CT columns, and then PCT columns, and then PST columns, we really couldn't get the real sense of when we have avalanches in real world environment, how fast they actually go. Okay? And so they figured out that if we do things in really steep and lengthy environments, we come to these real conclusions of where the how fast these things go. And so they call this theory a super shear crack propagation regime. And it says that this transition to this speed occurs if the crack propagates over a distance larger than the so-called supercritical crack length, which they measured at 5 meters. Okay? Another thing about this is they know that this speed goes more in down-up slope direction than from horizontal. So like, I don't have these videos, but they're like super cool. When they look at these pixel analysis of this movement underneath in the avalanches and how fast it moves from wherever the weak layer is getting diminished into the ground. So much happens before the sphere in this picture, who happens to be one of the SLF researchers, by the way, gets avalanche. And no researchers were killed in this situation. But anyway, Cobelier is amazing. It was amazing work from a lot of people, honestly. And in these slides, you'll see I have a shortened title and the authors on them, so that you can go back and. Okay, so wait, I need a test bomb that's larger than 5 meters. Okay, sweet. Andy Monroe, are you ready for the next step? Anyway, Andy's actually going to talk about his research this afternoon, but I just wanted to shout out for him. Anyway, so there's a bunch of this research that has to do with the crack speed and propagation distances, and Van Hervenen from myself also did these really cool experiments with small and safe slopes. So he would go and trigger these things, and what he was really wanting to look at is how far these cracks in breakers will propagate and how this distance could be predicted. And it's not just like fun work. I mean, this would mean how large will these avalanches be? That's the real world situation there. So they're trying to figure out these crack speeds in field measurements, field experiments with accelerometers to figure out how fast, how is the crack speed and the distance related. Pretty close. Okay, all right, so we're moving in from like actual avalanche mechanics into snowpack modeling. And that's been another thing that I've been just observing in the last years. So I'm an omnivore, okay, for all things avalanche, but snowpack modeling really isn't been my jam until I entered the SFU program. I'm looking at people like John Sykes, so it's like, just like they're just cranking on these things and making things happen. But I heard so many practitioners say that feels like snowpack modeling is getting there, which means it's more applicable or pretty close to be able to have some sort of operational value. So it's not just like theoretically interesting anymore. They're trying to have these snowpack simulations providing some insights so that the practitioners could apply it into their challenges. And Florian Herla is also from the SFU Avalanche program. We had a series of different papers. So this is just one of the snowpack modeling papers that were presented. But I did not rig the voting, even though I'm in SFU. Many people in my peers said that they really enjoyed this. But regardless, snowpack modeling has come a long ways, and maybe, I don't know, what do you think, John, in 20 years, 5 years? Well, so we're getting closer, so it's not just like fancy stuff with R and a bunch of simulations, it's actually going to happen. Okay, so then another big thing that I want to take away is that people are doing a lot of work in all the continents, trying to figure out what kind of number is climate change doing on avalanches. And I'm just highlighting here two of the papers that climate change is really predicted to change the temperatures, precipitation, atmospheric circulation patterns, and we should pay attention how it's going to influence the snow stratigraphy and the stability. And so it's still unclear, but there's more and more work done in order to understand it. And there were several research projects that had to do with dendrochronology, where people are trying to look at longer patterns than 30 years of data, looking at three growth disturbances in many places. And I think this specific patch study had one of the locales was in Southeast Juneau. Mike, were you involved with that? Cutting some tree cookies and looking at stuff. So these guys studied 3 different snow climates in North America and looked at the large magnitude avalanche frequencies. And not only important work in itself, but that would give us better idea how to predict how things are happening in the future. Another interesting thing that I just wanted to highlight here had to do with Stephanie Meyer, who's actually a super rad woman. She's a Swiss avalanche researcher, and she's just coding like the best of them. But she looked at, she ran snowpack simulations with different emissions models and came up with the predictions for the end of this century. And you should read her paper, but the gist is that there will be less snow, and there will be more wet avalanches, and that's one second, just want to see my notes here. So the dry snow instability, dry snow instability will decrease 20 to 60% by the end of this century compared to the reference period, while wet snow instability will increase by as much as 20%. So, stop driving those cars. Huh? Okay, so the next theme is consistency of avalanche forecast. So Anne was kind of like reading to this. Her talk was about how the users understand it. But this is kind of nice that Avalanche forecasters are really trying to work into more consistent data. And these are just like 3 different studies from 3 different locations. So Meter was looking at the spatial consistency across avalanche danger ratings in several different forecasting centers in Eastern Alps. And they were just looking at where are they consistent and where they're not. CIC actually did a verification study. They looked at, they asked forecasters to do the forecasting again later on in the day, and they looked at how consistently they would have done it now that they were just getting the data. And then in Canada, Portland was looking at, that's kind of like the consistency of using all these different avalanche problems between different forecasts. And I mean, it's good research, but the idea is that forecasters want to do their work better, and they want to have higher quality products. And we just need to see that people are actually researching how well they are doing their work. Okay, but following up on Anne's setup here, there was also a lot of research about how people are in the avalanche environment, and I'm just showing a few different research projects here. I want to highlight Annie Neveduk's work. She was characterizing increasingly diverse and growing backcountry community beyond the point of like, are they going out with snowshoes or snowshoeing? And she used really large data set from Europe, over 5,000 people. And you can look at a lot of different variables and start doing cluster analysis, so looking at what kind of patterns emerge from the data. And she was looking specifically risk management practices. So she was able to put people into different type of risk management characteristics depending on how they work. And why does this matter? First of all, we have to understand that we are more than just a skier and a snow machiner. We are like actual people, individuals doing different things, and we don't do any justice if we just think of others in that way. And then it can also inform what do people need, what do they do in order to keep themselves safe out there. And for the professional point of view, I wanted to highlight McGuire's work on mental models. So just when Paul was talking about, he was like recalibrating his mental model of what's going on out there looking at him. The idea that McGuire's work has to do is that we are all making mistakes all the time because our mental models are inefficient and incomplete, and that's how we are as people. So idea is to normalize mistakes and getting away from the deficit model and help each other to plug in different pieces of mental models, helping each other to learn. And we do that really well in Avalanche practitioner world when we are sharing our experiences and asking questions together. So that's how okay, so for educators here in the world, I want to highlight 2 different studies. And sorry about this picture, this was the best picture I could get off from this table. So Ian McCammon, coming out from the retirement and plugging in a research on how we use our inclinometers, and that we actually, regardless, there are some inclinometers that are better than others, but there's plus or minus 4 degrees of error with the common use. And he's like, well, that doesn't seem that much, right? But if it's 28 or 32, that's a lot, that's a big difference, right? And he created this really interesting kind of like risk multiplication index, where he said that, well, actually, if you're blowing it 4 degrees, how much higher your risk taking is. And so for your educators and practitioners, let's hone it down a little bit. Pay attention to how we are teaching this and how we're using the tool. Kelly McNeil had done a study with Barry. We should give them a shout out. They're actually looking at how well the education works, and they have a really solid, rigorous study on how what are actually like after the course, what are people doing? So is education working or not? And it's really important to look yourself in the mirror and see if you're making any difference. And I could not help but finish off my little social sciences spiel here, saying that while social sciences are gaining more space, we can all do better. So for a while, there were a lot of people are interested in social sciences because we can read that self-help book and we can grasp onto that, and then we're gonna put that in our Avalache context and talk about it among ourselves. But there's actually rigorous social sciences that are done, and they can really help us to improve what's going on in this world. But don't believe everything that you read. You should be critical. And you should collaborate. And this specific paper was done in collaboration with a lot of people who did really good work in this world. And they did really awesome call to action for all the different groups. If you're a research user, like many of you are, or if you're a researcher. Okay, I'm going to try to wake you guys up with a few things here in the end, because we often go to ISW to hear about some big cycles and whatnot. So I want to highlight three studies that were just phenomenal. There was a good oral about the Colorado mega avalanche from 2019, and the way how they did their work on looking at these huge tree rings and making sense of it. And there was another tree-ring study from Europe that was really amazing too, after the avalanche cycle in Romania. Another very common theme was RAC's work, so the remote avalanche control systems, and there was a phenomenal talk by this G2 Avalanche project in Kitimat, BC, for a power company. It was fantastic, and it was all about the RAC work and how they're making this mine being able to operate. But my favorite, and not very many people's favorite, was actually a social anthropologist presentation on this huge avalanche in Langtang, Nepal in 2015. And it was from these people's perspective in their village, their home, and how vulnerable they were in Nepal. That creates a very different meaning to think about that when you're living in real moments. Am I running out of time already, or can I keep going? Okay, so just bringing a few things in here, sorry. So urban avalanche planning is still lacking standards, in case you were wondering. We know it here in Alaska. But there was a talk about Juneau's vulnerabilities. And there are some people in Canada and in the US who are trying to work on some sort of multi-hazard risk assessment frameworks that could be put in. But you should pay attention to this because it should be coming up. And anybody snow machiners here who are real skiers? Oh, snow machiners, yeah, a few of them. There was exactly one talk that had to do with snow machiners. That's pretty sad. But luckily, and next ISW is in Norway. Well, in Norway, snow machining is illegal. So there won't be any talks about snow machines. But then the next one will be in Whistler, and hopefully there'll be some more talks about it. And I'm going to leave you with this thing. Just wake up for this slide. Stress is the inevitable aspect of avalanche work. If you're in this work, you have to pay attention to that and do anything that you can in order to keep this at bay. And there were great example of how avalanche workers in Colorado, with the support from the Exporter Alliance, are mitigating their stress in their work. They have really good tools that will probably fit in your work environment as well. And if you have time to read only 5+1 conference papers, this is them. You can take a picture if you want, or whatever. But if you're not even reading papers, you know, I have another thing going on for you, which is that they have these illustrated session summaries. So if you just want quick notes, you can find these from this website. It's pretty sweet. And then you don't really have to read papers. And I'm just going to leave you with thank you for all the contributors of the highlight. It was super fun to put this together. And thanks for listening.
Thank you, Eva. That's a whole week of science that you just squeezed into like a half hour. That's incredible.